Let's take it another step here, guys. Last video we took a look at mass to mass problems. This time we're going to take a look at volume to volume problems. Or in other words, we're going to take liters of one substance and change it into liters of another substance. Let's look at our flow chart to kind of figure out how we're going to flow. All right? We are going to start down here in liters of a given substance. We're going to start down in the volume step. We're going to take these liters of this substance and change it to moles. And remember how we go from liters to moles. We take 1 mole is equal to 22.4 liters. Let's try that one more time. There we go. 1 mole is equal to 22.4 liters. That's our conversion factor from moles to liters. So we'll be using that one again. Then we're going to take our moles of our one substance and change it into moles of a, and this should be moles, right? Moles of a new substance. So we're going to go from moles of one substance to moles of a new substance. And in order to do that, we use the conversion from our balanced equation. Once we're in our moles of our new substance, we have one more step. We're trying to get out to liters of our new substance. So again, we're going to use that same conversion that we had from before, from liters to moles. This time we'll be going from moles to liters, but same idea, 1 mole is equal to 22.4 liters. Another way to look at this or say this, guys, is that we're going from liters of one substance to moles of that substance. We'll take the moles of that substance, change it into the moles of our new substance, and then we'll change that out to liters at the end. That's how we're going to convert with this stuff. So let's take a look at an example problem. Number 1, it says nitrogen monoxide and oxygen gas combine to form the brown gas, nitrogen dioxide. How many liters of nitrogen dioxide are produced when 3.4 liters of oxygen reacts with an excess of nitrogen monoxide? Assume conditions of STP. Well, let's break this down real quick because there's lots of words in here that might throw you for a loop. Don't let them confuse you. You can do this, right? STP, right? Let's break that down. Remember that STP means standard, temperature, and pressure. All we're saying is that we're going to measure this liter at a temperature of 0 degrees Celsius and a pressure of 1 atmosphere. And what that allows us to do is use this conversion, that 1 mole is equal to 22.4 liters. That's a conversion that we've been using. So that's what STP means. Excess of nitrogen monoxide, what they mean by that is that you will have plenty of this nitrogen monoxide for this reaction from oxygen to go and change into nitrogen dioxide. So don't let these things confuse you. Let's figure out our equation, balance it for our first step. Nitrogen monoxide. Well, first off, you've got to recognize that this is a covalent compound because of the prefix mono. And if you remember, mono means 1. So what that means is I have 1 oxygen. Now, I don't have a prefix in front of nitrogen here, but if I don't have a prefix, that means that I also have one of these. So I have a compound that has 1 nitrogen and 1 oxygen. That's nitrogen monoxide. The next thing I have in here is a word and. The and is just my plus sign in my equation. Then it says oxygen gas. Well, oxygen is just the symbol oxygen. The only tricky part with that is you have to remember that oxygen is a diatomic, so I have to include that 2 as a subscript. And then it says combine to form, and that's my arrow as I just drew, the brown gas nitrogen dioxide. This time I have a prefix of di. Di means I'm going to have 2 oxygens. Again, I don't have a prefix in front of the nitrogen. That means that I have 1 of these. So I have a compound with 1 nitrogen and 2 oxygens. That's my compound. Now I have to balance this equation out. Now this one's a little trickier where you start on. This is one of the times that you're not going to take 3 and make it into 6 or 3 and 2 and make it into 6. Let's take a look. I have 1 nitrogen on this side. I have 1 nitrogen on this side. So I currently have 1 nitrogen on this side and 1 nitrogen on this side. On the oxygen, I have 1 oxygen here, but 2 more here. So I have a total of 3 oxygens on this side and 2 oxygens on this side. Now what I want to do is actually get rid of the 3 on this side, and instead of making 6, I'm going to make an even number of 4. So in order to do that, I'm going to put a 2 actually in front of this NO, the nitrogen monoxide. This gives me 2 oxygens here, plus the 2 that I have over there. That's going to give me 4 oxygens. Now because I have 4 oxygens on this side, I want to get 4 oxygens on this side. And to do that, I have to put a coefficient of 2 out in front of the nitrogen dioxide. This gives me 2 oxygens times 2 oxygens here, which gives me the 4. This also gives me 2 nitrogens here, and this gives me 2 nitrogens here. So now we have our balanced equation. A 2, nothing in front of this one, so we just keep it as a 1, and a 2. Let's clean this up. I'll see my same equation right here that we just looked at. 2, 1, 2. Clean everything up so we can try this problem now that we have the equation balanced. All right, so let's take a look at how to start this problem. Now, I was given 3.4 liters of oxygen. So I want to put the oxygen there. I'm going to take that value, I'm going to put it over 1, just like we've done every time, all the time. Take what you're given, put it over a value of 1. That's the word mole, not the number 1. There's our number 1. We're going to multiply this by a conversion factor. And let's take a look at what we're going to convert to. We are starting out in liters of oxygen. My first step, if you remember, is that I want to convert to moles of my oxygen. So, how do I convert a liter to a mole? Well, here is my conversion factor right here. If you remember, we looked at this before. 1 liter is equal to 22.4, 1 mole is equal to 22.4 liters. Let's set this up. Let's take our conversion factor here. I have liters of oxygen up on the top here. Whatever unit I have up on top has to go down on the bottom of the next step. So I'm going to take my liters of my oxygen, put that down on the bottom so they cancel out. And I'm trying to go to moles of oxygen, so I want to put that up on top. And like we just said, 1 mole, so I want to take this 1, put it next to the moles in my conversion, is equal to 22.4 liters. So take the 22.4, put that next to my liters in my conversion. Now let's cross this off. My liters are gone. Now I'm in moles of oxygen. So what's my next step? Well, I want to take my moles of oxygen, and I am trying to figure out how many liters of nitrogen dioxide I can produce. So I'm going to take my moles of oxygen and actually change this to moles of nitrogen dioxide. So let's take a look at what we've done in this periodic table, or this flowchart so far. We've gone from liters of oxygen here to moles of oxygen. Now we're going from moles of oxygen to moles of NO2. And if you remember how to do this one, this is our mole to mole conversion. We are going to use the mole ratio from our balanced equation. So that's how we get this conversion from 1 mole to another mole. Right? So what I want to do is set this problem up, just like we've done every problem, multiply by a conversion factor. Whatever I have up on top is going to go down the bottom. So I have moles of oxygen here up on top. I want to put moles of oxygen down on the bottom. Whatever I want to go to, and I'm going to moles of NO2 is going to go up on the top. So moles of NO2 is going to go up on the top here. Now how do I get this step here? Again, we talked about this. We just saw this on the other part. This comes from my equation. So let's take a look at my equation and figure out what I need to put in here. In my equation, I have a coefficient of 1 in front of the oxygen. That's what I want to plug in here. For the nitrogen dioxide, I have a 2 in front of it, so that's what I want to plug in there. That's how I take that conversion, moles of oxygen into moles of NO2. Now that I have my moles of oxygen on the top and bottom, I'm gone, those are gone, and now I'm in moles of NO2. We got to keep going, however, though, because they ask us to solve for liters of NO2. So I got to do another step here, another conversion factor, and whatever was on top goes on the bottom. So I had moles of NO2 up on the top. I got to put moles of NO2 down on the bottom again. And what am I trying to go to? Well, I'm trying to go to liters of this NO2 here. So I'm trying to take this step from moles to liters. And we know that conversion because we just used it before. 1 mole is equal to 22.4 liters. So let's put my liters up on top, and I'm trying to get for liters of NO2, so I want to label that. And it says 1 mole is equal to 22.4 liters, so the 1 goes next to the moles in my conversion, and the 22.4 goes next to the liters. And now what I've done is I've converted my moles of NO2 into liters of NO2. Let's do the math, and let's figure out what the answer is. Up on top, I have 3.4, I have 1, I have 2, and I have 22.4. And those numbers, when you multiply the top together, you get a value of 152.32. Down on the bottom, I have 1, I have 22.4, 1, and 1. So on the bottom, I'm dividing this by 22.4. And when I do this math, I will get an answer of about 6.8 liters of NO2. There we go. Let's take a look at one more example. Now, using the same equation, so same equation, there it is. We just converted it from the last one, so we don't need to do it again. This time, we are looking to solve for liters of oxygen. So I'm looking to get how many liters of oxygen will I need if I start out with 10 liters of nitrogen monoxide. So I'm starting out with 10 liters of this. We're trying to convert it and figure out how many liters of oxygen I'm going to need to make the most NO2 that I can get. So I'm starting out with 10 liters of the NO, and I'm trying to convert it to however many liters of O2 I need. So we look at the flow chart. Again, I'm starting out here. Let's erase what we did last time. This time I'm starting out here in the NO with liters, and I'm trying to convert to liters of O2. So my first step is taking my liters of NO and going to moles of NO. Let's do it. Take what we were given, let's put it over 1. 10 liters of the nitrogen monoxide. Let's take it and put it over 1. Multiply by a conversion factor. You know what goes on the bottom of the next step. I got liters up on top in my previous step, so I'm going to take liters of NO, put that on the bottom right away, and I'm trying to go from my liters of NO to moles of NO, so I want to have my moles of NO up on top. So here I go. How do I convert a mole into a liter? Here's my conversion factor. Well, it says 1 mole is equal to 22.4 liters. Because I have the moles on the top and bottom, excuse me, the liters on the top and bottom, my liters are canceled out, and now I've gone to moles of NO. Let's take our next step here. I'm in moles of NO. I want to get to moles of O2. So I want to actually have moles of my O2. This is the conversion that I'm trying to make. Well, how do I convert from 1 mole into another mole? Well, let's set this up. Multiply by a conversion factor. You know that moles of NO are going to go on the bottom because you have them on the top in the previous step. And you know we just said that we're trying to convert to moles of O2, so let's put that on the top step. Remember, this step right here, this conversion is going to come from my equation, right? So this conversion from moles of one substance to moles of another comes from our balanced equation. So what do I have? Well, in my equation, I have a 2 next to the NO, and I have a 1 next to the O. So I want to put a 1 next to that on top and a 2 next to the NO on the bottom. That's my conversion factor. Now because I have the NO on the top and the bottom for the moles, I want to cancel that out, and now I'm in moles of O2. I had to keep going. I have to do one more step. So we have to take this down to the next level here and do our final step. I'm converting my moles of O2 now back out into liters. So I have to multiply by a conversion factor again. I had moles of O2 up on top, so I'm going to put my moles of O2 down on the bottom. I'm trying to go from moles of O2. I'm taking this conversion, going to liters of O2. So I want to have the liters of O2 up on the top. And my conversion is that 1 mole is equal to 22.4 liters. So 1 goes next to my mole, 22.4 goes next to my liters. And now let's convert those moles of O2 into liters of O2. Moles cancel out, liters are up on top. Let's do the math and let's figure it out. Up on my top, I have 10, I have 1, I have 1, and I have 22.4. That's going to give me a value of 224 up on the top. Down on the bottom, I have 1, I have 22.4, I have 2, and I have 1. That gives me a value of 44 down on the bottom. When I do 224 divided by 44, I'm going to get approximately 5 liters of oxygen. That's my answer there. Hopefully you guys can catch on to the volume-to-volume problems, taking liters of one substance and changing it into liters of another substance using our flow chart through stoichiometry. Talk to me if you have questions. We'll figure it out. We'll do some problems in class. Have a good one.